Yes, let's start.
Okay. Happy evening to Emmanuel Arriaga from US and other participants joining from US, Canada. Happy morning to folks from India and a happy afternoon to folks from Singapore. We do have people from in India, people from not only Chennai but also Salem, Bangalore participating in this session. Pleased to welcome you all to this Spin Chennai's big conference session with Emmanuel, the international practitioner from Google. We are navigating in a world with a lot of uncertainties and opportunities side by side. If you look at digital transformation, there is a huge opportunity. Whereas if you look at the brick and mortar kind of operations, there is a lot of uncertainty. So before Emmanuel gets to talk, I have the pleasant duty of doing three things. Brief intro about Spin Chennai to Emmanuel and to those who are new. Set the context for the session. Third, introduce Emmanuel. Spin Chennai, a little short of 25 years as a knowledge. Spin Chennai is affiliated to CMU, Carnegie Mellon, and Software Engineering Institute, as well as ISACA, the global body. Our vision is to build a world-class knowledge ecosystem, which is very compelling, highly relevant, and value-adding to the people, the individuals, as well as the industry, distinctively futuristic and passionately co-creative. We have a 3,000 member knowledge ecosystem comprising of CXOs, board members, senior leaders, SVPs, VPs, HR, marketing, sales professionals, quality and delivery professionals who form a core part of Spin Chennai, BFSI, telecom, automotive, manufacturing industry folks, senior consultants, mentors, academia, and various other institutions. Some of the international gurus who have been associated with Spin Chennai include Dr. Watts Humphrey, who was associated with us for nearly 10 years, in whose honor we have instituted the Watts Humphrey Awards, which happens every year with huge participation from the industry, which brings out the best case studies from the industry. We have had several other international gurus associated with Spin Chennai, including Louis Trigger from Israel, the theory of constraints expert, who is a direct disciple of Eli Goldratt, the author of Theory of Constraints. We had Dr. Bill Curtis from US, who has contributed to the development of the world famous CMMI model, People CMM model. Professor Manu Ora, who is one of the top management consultants in the US. Mark Johnson, who is a management thought leader and a co-founder of InnoSight, along with Dr. Clayton Christensen, professor of Harvard Business School. Dr. Jeff Sutherland, co-founder of Scrum. Mr. Michael Krigsman, author of CXO Talk with more than 1,000 appearances. Mr. Barry Kriggs, ex-Microsoft CTO for IT. Steve Beres, who is a partner at Bain. And so many other leading lights from India have been part of Spin Chennai during 2020 and 2021. They have people like Jeff Sutherland, co-founder of Scrum, was here 2 times last year itself, 2020. So we have had fantastic thought leadership sharing during 2020, 2021. And we have been continuously getting global thought leaders. Today's session is one in that direction. So coming to today's session, there is a saying, sometimes absence of something is felt more than the presence of something, right? So if you take, for example, SRE or Google search, the Google search engine or the YouTube, they are all shining examples. Even if you take away even 1 minute or 2 minutes, the whole world will will stop. So in 2013, Google went down for 5 minutes and the internet traffic globally dropped 40%, right? So you can see the suffering when something like that, which is like your livelihood, which you frequently access, goes down. So that is YouTube. If you take YouTube, for example, the ad revenue itself, if you take 2020, it is $20 billion, right? And there are 2 billion users across the world, and it is continuously growing exponentially. So the site reliability engineering is a very, very important discipline that incorporates aspects of software engineering and applies them to infrastructure and operation problems. The main goals are to create. Yeah, just a second. I'll switch off the. Sorry about it. Yeah, sorry about it. Yeah, the principle. So the main goals are to create scalable and highly reliable software systems. Google is one of the originators of SRE as a discipline in the early 2000. Site reliability engineering uses software engineering to automate IT operations, like production system management, change management, incident response, uh, emergency response, otherwise be performed manually by system administrators. The principle behind SRE is that using software code to automate oversight of large software systems in a more scalable and sustainable strategy than manual intervention, especially as those systems extend or migrate to the cloud. So today we have SREs for GCP, SRE for AWS. There are so many SRE which are even more customized to the specific clouds. SRE can also reduce or remove much of the natural friction between development teams who want to continually release newer updated software into production, and operations teams who don't want to release any type of update or new software without being absolutely sure of outages or other operation problems. As a result, while not strictly required for DevOps, SRE aligns closely with DevOps principles and play an important role in DevOps success. The concept of SRE is credited to Ben Trainer Sloss, VP of Engineering at Google, who famously wrote that SRE is what happens when you ask a software engineer to design an operations team, right? So there are, if you look at the differences between SRE and DevOps, while DevOps is a modern way to deliver high quality applications faster by automating the software delivery lifecycle and by giving development and operations teams more shared responsibility and more input into each other's work. So SRE, for example, if you take DevOps principles, reduce organizational silos, leverage tooling and automation. SRE practice, each DevOps principle has an equivalent SRE practice. Use the same tooling to automate and improve operations as developers use to develop and improve software. If you take the DevOps principle, accept failure as normal, implement gradual changes. The SRE practice, if you consider equivalent, use error budgets to continually deploy new features and function within acceptable levels of errors. DevOps principle, measure everything, right? SRE practice, base decisions to release new software on SLA metrics. So they kind of closely complement each other. So today we will be listening to a whole lot of interesting stuff around YouTube and Google and the way billions of users, today when people design systems, particularly for YouTube kind of thing where billions of users are involved, SRE practice becomes one of the best in the world. So Emmanuel is going to talk about all those, share his experiences. So coming to Emmanuel, he's the YouTube SRE based in Bay Area. He's a technical program manager at Google YouTube Site Reliability Engineering practice. He leads the technical program manager in Google Station for release engineering as well as release management and Agile Scrum governance of 80 person engineering, 80% engineering department as part of the next billion users product area. So he is also the people manager for technical writing. He manages strategic initiatives and quarterly planning. He manages the program portfolio for the logs policy team. And he has performed a privacy reviews as part of the Privacy Data Protection Office, PDPO. So he's the author of award-winning novels such as Elevator Quest and the Foundra series. Very, very interesting profile. I saw his LinkedIn. He grew up in the inner city of Philadelphia in Pennsylvania. From a young age, he was obsessed with fantasy and science fiction. Breaking the shackles of the low-income life, Emmanuel developed an interest in science, technology, and engineering. He went on to graduate from Pennsylvania State University with a master's in information science. For almost a decade, Emmanuel has sought to share his vivid imagination with the world, learning the art of story and eventually becoming an award-winning author. With a love for travel, gadgets, and volunteering, Emmanuel is enjoying life and helping others. This is a fantastic. Thanks for being with us, Emmanuel, today morning in India time and today evening to you. We're really fortunate to have you share your thoughts with us. So for the delegates, please keep updating your questions in the chat facility available. At the end of Emmanuel's talk, I will be relaying some of the relevant questions to Emmanuel for his response. In case we do not have time to get all your questions answered in this session, Emmanuel has agreed to respond with his answers later, which we'll be relaying it back to you. Please keep your audio in mute and only when called for, you may unmute. So SRE is a very, very important agenda item for Spin Chennai that we want to take forward with its member organizations. So without spending any more precious time, I would like to invite Emmanuel to enlighten us on what he sees are important items for organizations to succeed with SRE. I encourage, at this point, I would like everyone to unmute, each and every one of you to put your hands together to welcome Mr. Emmanuel to address the Spin Chennai community. Thank you. Over to you, Emmanuel.
Thank you. Thank you for the great introduction. Let me go ahead and share my screen for the presentation. All right, can everyone see my screen?
Yes.
All right, perfect. So yeah, thanks for taking the time to come and listen. Like mentioned, my name is Emmanuel Arriaga. I work for Google as part of the YouTube site reliability engineering team. I'm responsible for production health. I have a team, a horizontal working group team where we work across YouTube, focused on incident management lifecycle. So a lot. I'm going to give a general overview of site reliability engineering and then dig into the incident management side of things, talking a little bit about how you can help reduce incident impact. So let me go ahead and get started. So in this talk, we're going to discuss 5 key areas. First, I'll talk about the core problem that SRE solves and the high-level organizational structures that facilitate the practice of SRE. Second, I'll talk about the key principles SRE use to keep systems appropriately reliable. Third, I'll talk about the key areas of responsibility and expertise SREs have. And then finally, I'll summarize the essentials of SRE and discuss how to adopt SRE within your organization. So let's start by talking about the core problem that SRE solves and the high-level organizational structures that facilitate the practice of SRE. We're here to talk about the operational cost of software. Software engineering is typically focused on designing and building, not so much on operating, even though running the software once launched is far more expensive, up to 10 times the cost. In my experience, organizations often focus on hiring good software developers and don't really care too much about operations. It's often seen as someone else's problem. Incentives aren't really aligned. Developers build new features, throw things over the proverbial wall to the operations team, and move on to the next thing. Meanwhile, operators juggle everything being thrown at them while being responsible for everything from scalability, reliability, and maintenance of the software. In other words, developers want to go as fast as they can, while operators are looking to slow things down as much as possible to reduce risks. It's a pretty terrible setup when you think about it. It's not designed for harmony. Instead, it's brittle and doesn't scale well. It also establishes silos. There are some techniques for dealing with this. There used to be a wall between product management and product development, and Agile solves that problem to some extent. And then DevOps also came along roughly at the same time as SRE and said, you need to resolve the tension between development and operations to achieve better reliability and agility. Let's break down DevOps. There are many definitions of it, and here's my definition. DevOps is a set of practices and guidelines that say how you're going to break down these silos. First of all, it tells you that you need to break down the wall between development and operations to help with collaboration and velocity. Second, we know things are going to break, we plan for that, and then we accept that failure as normal. Smaller changes are easier to implement and deploy, which makes them easier to roll back, which helps with mean time to repair. We also want to remove human error from the equation as much as possible, and we do this with tooling and automation. And then finally, we want to measure everything because measurement is critical to determine success, especially in the above 4 areas. Watch throughout the rest of this presentation for how SRE implements each of these practices. Both SRE and DevOps intend to solve the same problem of reliable services at scale and converge on similar solutions. So how is this similar to SRE? You know, SRE says that we need to use data to guide our decisions, and we need to treat operations as a software engineering problem. For that, you need people with software engineering skills who will be capable and motivated to automate operations away. We also know that we need to design our systems to be reliable from the start rather than bolting on something after the fact. In a nutshell, here's what we do. We write software and design systems that operate scalably, reliably, and efficiently. It's a combination of 3 things: a group of people, a set of philosophies and mindsets, and a set of engineering practices and toolings. You need all of these. DevOps is really a cultural practice to break down the silos between the various teams. Site reliability engineering is a set of those practices we found to work in a job role. At its core, SRE is just one principle: error budgets. To talk about error budgets, we have to talk about reliability and specifically about how to measure reliability. The simple and somewhat naive way to do this is by measuring how much time things were good overall in the measurement window. This is nice, it's intuitive to understand, and fairly easy to measure for things that are continuous. For example, a web server, is it up or down? It doesn't work as well for more distributed and complex systems. For these, we need fancier definitions of reliability that can also handle whether your service is partially up or down, and to measure the quality of the service. You know, one approach is to look at the number of good interactions over the total number of interactions. What's important, though, is to have a definition for reliability and a way to measure it. Next concept is that there's a certain amount of reliability we're trying to reach. You've probably heard of 3 nines or 4 nines of service. It's really about the amount of downtime we're willing to tolerate. But remember, it's not just time being hard down that assumes a 100% outage. There's more nuance and room to maneuver if you can measure brownouts and not treat them as 100% errors or 0% errors. You may be thinking, there's a number missing here, 100%. Well, so the key realization that Ben Traynor-Sloss, the founder of SRE at Google, had was that 100% is the wrong reliability target for everything. This is where error budgets come from. What do we do instead of 100%? We need to pick what is going to meet the needs of our users. Are people going to notice things being down? This really is mostly a product management concern. The amount of unavailability you are willing to tolerate is your error budget. And of course, you need to measure that. Once you know how much your error budget, once you know how much of your error budget you have left, you're able to choose how you're going to spend that error budget. For example, shipping new features or doing experiments. This is powerful. You now have an objective way to measure reliability, and whether you're meeting your agreed upon business goals. Suddenly, you're finding that both devs and SREs are working to balance development velocity with reliability. Both sides are working together, and devs are empowered to manage the risks themselves. Likewise, SREs know what to focus on, improving reliability or other things that they also care about, which we'll talk about. Here's how we talk about error budgets. It boils down to 3 terms: SLI, SLO, and SLA. The indicator tells you at any moment in time how well your service is doing. Is it doing acceptably or not? The SLO aggregates that over time. It's the mathematical equivalent of error budgets. It says over this window of time, this is my target and how well am I doing against it? The SLA is mostly relevant to a business. It defines what you're willing to do, such as refunding money if you're failing to meet your objectives. Defining SLOs is a really complex topic. I can't really describe all the nuances in the time we have, but the important thing to do is to come up with a simple SLO first and then iterate on it over time. You can use the totality of a primitive metric to set up priorities and then decide what you want to do. SLOs require buy-in from the business, development, and operations. They bridge all three domains and give them a common language, unlike pure Agile or DevOps. With just SLOs and error budgets, we already covered 3 of the 5 key areas of DevOps. So the concept of SLOs and error budgets are all good and well, but how do we actually defend them from day to day? We need to work in a few key areas of practice. And those are metrics and monitoring, capacity planning, change management, emergency response, and the actual culture of your organization. I talked earlier about measuring your SLOs, and this is where monitoring alerting comes from. You need to measure how well you're doing against your targets, and you need to have high quality alerts that fire only when your error budget is threatened. And finally, you need to be able to dig in when an alert fires and figure out what's gone wrong. Capacity planning, even if the cloud scales infinitely, your CFO surely cares about the cost of running your services, right? You need to plan for both the organic growth, such as signups for new users, and the inorganic growth that comes from launching new features that consume more resources. To do this, you need to be able to correlate the capacity of your service and resources consumed by it. The other side of capacity planning is efficiency and performance, and someone needs to own this as well. Let's tie it back to SLOs for a moment. It doesn't make sense to you to have your service run super fast because you're over provisioned by a factor of 10 and are wasting 90% of your resources. On the flip side, it also doesn't make sense to.
Yeah, Emmanuel.
Yeah.
So sorry to interject. So can we slightly slow it down? I think it looks like we are going slightly fast.
Sure. Yeah, not a problem.
Thank you.
What I was saying on here, if you're over provisioned by a factor of 10, for example, and you're wasting 90% of your resources, that's not good. But on the flip side, it also doesn't make sense if you run your service at 110% utilization. Have your latency degrade and to have to tell you unhappy users, that you're and have unhappy users, right? You're also ultimately be burning your error budget. So you have to strive for something in between. The other thing to watch out for is regressions. You can do this by detecting when your error budget is threatened and addressing capacity, or better, by detecting that a new release is causing problems and rolling it back rather than throwing more resources at it. At Google, we found that about 70% of outages are caused by changes made to a live system, whether it's a new binary or a new configuration being pushed.
Sorry, I didn't understand.
And we're constantly making changes to our systems. So how do we manage that risk? We try hard to make global change, to avoid making global changes, and instead progressively roll out changes over hours or days. We have good monitoring. We want to have a low time to detect. And we want to have a low time to repair, making sure that changes that are being pushed have easy and safe rollbacks. Those are best practices, and we also work to automate these. Good change management is about managing risk, and the approach is to try to make all these changes a routine process or standard change. ITIL terminology for those who love that. The goal here is not to go slow. On the contrary, you should be going as fast as you can. That is, until you exhaust the error budget. Then you need to slow down. At the intersection of change management and capacity management, You have provisioning, which is about quickly and safely changing the size of an existing service, either by adding additional instances or locations or removing them. Depending on the change, it can be fairly complex, which means it's risky and needs to be managed carefully, preferably through automation. The fourth key responsibility of SRE is dealing with incidents. What happens when things do break? For many, this is fairly stressful. So it's important to have a well-defined process, and even more important to practice these so that when you are facing a real incident, you don't panic and focus instead on what matters. Restoring the service to a healthy state by mitigating the issue. Once that's done, then you can work on the longer term work of troubleshooting and fixing the actual problem so that it won't happen again. It really is a team effort in this, and the larger the incident, the more people you need to pull in, SREs obviously, but also devs. One of the most important failure modes that I see is that a lot of people don't pull in help when they need to. Often they are so caught up in the incident that they don't even realize they need help. An important part of the process you need to define are incident thresholds. When are you going to declare an incident? When to bring in other responders to help? This typically is how much damage you've done to your SLO, how much of your arrow budget you've consumed. If you're on track to run out of your entire arrow budget for the quarter in the next few hours, you probably want to declare an incident. On the other hand, if you have it under control and your error budget isn't at risk, then you can spend a few more hours to look at what's happening on your own. Define these thresholds ahead of time so that when things do go wrong, people don't have to wonder or worry about whether to declare an incident. Just within YouTube, we have very clearly established guidelines around when to declare an incident and what qualifies as an incident as well as the severity of the incident. So we would rather for, if anything goes wrong, declaring an incident and then evaluating what level of severity the incident is after the fact. That way we can remediate the issue and prevent outages, because our platform does service 2 billion users. Afterwards, your focus is really always preventing the problem from happening again, making sure you really figure out and understood the contributing root causes and are planning work to improve the reliability of your service. The kind of work you want to do typically falls into the following categories: things that will prevent a recurrence of the problem you've encountered, things that will help mitigate future incidents caused by this class of failure, by either A, mitigating issues you've uncovered to reduce the severity and scope of future incidents, or by B, making it easier to recover quickly the next time such an issue is detected. Finally, the critical things with postmortems is blamelessness. Humans are never the cause of incidents. Remember, we treat operations as a software engineering problem. So when things go wrong, we look for the flaws in the system that allow things to go wrong, and we look to improve things to avoid human errors. If you really want to learn all you can from an incident, you need to be able to get to the bottom of things, and you cannot do that if people are scared. Everyone makes mistakes. That's not the problem. The problem is when your system allows these mistakes to happen. So let's look at how a service outage affects user happiness and define some vocabulary about outages. In general, user happiness falls when the outage is ongoing and rises during periods of stability. So let's break this down into phases. From the start of an outage, or when the outage begins, to when an alert fires and is acknowledged, triage begins. This is your time to detect. Then when the issue is mitigated, this is your time to mitigate. And then that time lapse between when the next outage begins, that's your times between failure. So what did this outage just cost you? These are direct costs like lost revenue. There may be people who are now so frustrated with your service that they're never coming back. And friends of those people may have brought that will never become your clients. How much bad press did the outage generate? How many angry tweets? So here's the question: if you had a choice, how much would you pay to avoid this outage? Just going back to examples from YouTube again, we have very clear thresholds around, we're looking at things like, is there a social media spin around a particular issue, or, are people on Reddit complaining about this? Are people reaching out to our Twitter account with reports of this incident and what's the number of those things. All these factors come into our consideration of the incident severity and the ultimate impact. Once you have a critical mass of postmortems, patterns will start to emerge and you'll be able to identify where you should focus your engineering effort. This is, of course, not an exhaustive list, but these are some specific engineering tasks that we found have a strong impact on improving the 3 outage lifecycle phases. Tasks that improve time to detect are about defining and measuring failure. Tasks that improve time to mitigate are mostly about preparing the responders and their environment. And tasks that improve timing between failures are mostly about engineering discipline. You're having an outage when your error budget starts burning so fast that if the issue is ignored, it will eat up all your remaining budget. I mentioned that before. It's an important thing to keep in mind. The time to detect is from the start of the outage to when a person that can actually work on fixing that issue is alerted. Remember, a person on call for a service, as a person on call for a service, you can't even begin to triage a problem until you know about it. If your postmortem show a significant amount of impact to users in this phase, we need to tighten this up, and that's usually a good signal. Your SLIs drive your alerts, so it's important that your SLI, for your SLIs to give you a good representation of the end user experience. One way you can make this happen is to measure as close to the user as possible. This means that if you can, take your measurement from the client. If you're measuring a latency or availability SLI, it is the latency and availability at your client that matters to your users. You want to include the flaky links between your services, between your service and your client. If you know that your users need to sub 500 millisecond response time, measuring at a client may show you that you need to architect your service to deliver 100 millisecond latency at the load balancer. Of course, some of the problems you catch aren't your fault, but just because it isn't your fault doesn't mean that you can't do anything about it. Sometimes you can't instrument the client for metrics, and that's okay. You just need to be aware that your view of the user experience has less precision. Another way to tune up your SLIs is to verify them against external sources. A good SLI will be up when your users are satisfied with your service in real life, and will be down when your users are frustrated. For example, if your last SLI show you're having a major outage, but none of your users are actually complaining, maybe you're measuring the wrong thing. Talk to your users or just monitor Twitter to find out exactly what bothers them and what doesn't, and adjust your metrics and use your SLIs accordingly. Just as you iterate with your SLIs, you need to iterate on your SLOs. Your SLOs are your target values for your SLIs, and you need to align them with your users' expectations. It is not usually obvious what your users actually need, so you should adjust your SLO targets over time as you learn more. It's particularly important to note that that if you set your SLOs too tight, do your users really need 4 nines reliability, or are they just happy with 2? Every additional 9 that is, for example, going from 2 nines or 99% availability to 3 nines or 99.9% availability translates to about 10 times the business costs due to engineering requirements and staffing. Running a 4.9 service is not cheap, so be sure you need to do it before you commit to business to supporting it. And finally, your alerts need to be consistently useful. You want alerts to fire only when actual users are being impacted. This, of course, goes back to the quality of your SLIs and your SLOs, but it's important to see how good quality SLIs and SLOs directly translate into alerts that engineers learn that they can trust are important. Along those same lines, you need those alerts to be both sensitive and actionable, but it's hard to get both at the same time. This comes down to a period of time that the alert averages over before it decides to fire. Alert too quickly, and you'll be paging at midnight for something that goes away in a few seconds. Alert too slowly, and you'll lose time you could be using to mitigate real outages. It can take some time to find the right balance. Focusing on these 3 should get your time to detect in a pretty good shape. Whereas shrinking time to detect was all technical tasks, shrinking time to repair is mostly about people, policies, training, and of course, stress management. Even if you have great alerting, what good is it if everyone panics when they get an alert? In my opinion, this is the most important section to focus on. You will always have outages. You can automate fast solutions to many problems, but not all of them. You hire engineers because they're smart and creative, and they're ultimately the best resources you have for fixing the problems that slip through the cracks. Of course, they're also the slowest way to fix a problem, but they're your last, most capable line of defense, so it pays to invest in them. A quick reminder before we begin this section, though, an incident responder's first duty is to protect the user. During an outage, keep your focus on mitigating the effects on users, not on finding and fixing all the contributing factors. So good responses, temporary failover, version rollback, emergency requests for more resources. Bad responses, debug the code, fix the code, check it in, build a binary, push it out. That takes way too long, and it's really risky too. How do you know your fix won't cause a different problem? Do that kind of stuff later when the service isn't actively burning. So what can you do to improve your time to mitigate? First, there it goes, it was lagging. You have to train your responders. You need emergency procedures defined and tested so that everyone involved can be calm and productive during an outage. Specifically, you need procedures that provide enough structure and protocol so that the response is organized, but you also need them to be open and flexible so responders can do ad hoc exploration. And don't just train the people on call. Include everyone who could participate in incident responses, devs, product managers, even CEOs. And don't just train them once. Incident response training gets rusty quickly. At Google, many teams hold weekly failure drills. These drills could be practical, where we actually modify services. Depending on the tests, these services could be the real user-facing systems, or they could be internal replicas. The drill could also be theoretical, where a team might just walk through how to handle the situation. The drills don't have to be complex at all. A simple example could be, users report that they can't log into a service. What do you do? Either way, the team gets experience with critical thinking, communication, and knowing when to escalate. Number 2 here is that you have to write an alert runbook. Some people call them playbooks. A runbook is the first thing an on-caller sees when an alert is fired. You need to write one for every alert that can fire. Critically important. Write down the things like special response procedures, links to dashboards, search queries for debug logs, everything someone who is handling the alert might want to know. I'm not saying you need to know every possible cause and fix before you even make an alert, but the runbook should give the responder a clue on how to start the investigation and where to go for help. Now, something that happens a lot is that someone writes a runbook, but then nobody else can understand it. When you write a runbook, even if you think you're just writing it for yourself, keep it simple. Write it for a version of yourself that just got back from a vacation and has completely forgotten how to do your job. You'll thank yourself later. This is actually a good opportunity for a failure drill. Send an alert to a volunteer and see if they can follow the runbook. Is there anything they had to do that wasn't in the runbook? Add it in, be thorough. It is just too easy to forget simple basic steps in the stress of an outage. Next, let's focus on the on-call responders themselves. Pager fatigue is a real thing. Being on call is a hard job. And if you want to keep your on-callers, you better make their happiness a priority. Over time, we found that incident responders can handle about 2 incidents per shift before they start to feel overloaded. This, of course, will vary between teams and companies, but it's a good starting point to aim for. You should automate routine operational tasks as much as possible. We call this eliminating toil. One classic example of this is release management. How much of your release process can you automate away so that you don't have to babysit? And if the load is just too high for an operational team, shed some of the load. Ask the development team to handle excess pages, or maybe you need to loosen your SLO until your service is stable enough. It's very common at Google where if a development team hands a support for an application over to an SRE team, if the application isn't stable, the SRE team will hand the pager back to the dev team and say, we're not fully taking this pager until the operation is more stable, right? And so, and that kind of creates this shared sense of ownership of reliability as opposed to that throwing it over the wall like we talked about before. Over time, and finally, dashboards and logging. Measuring everything is something of an SRE motto. Record every response code, every lock contention event, every queue length, and then visualize these metrics on task-specific dashboards to allow your own callers to get the data they need to make tactical decisions. A word on cost. Keeping metrics forever costs a good bit of storage. So it is good to set retention limits on your metrics so that only the ones you need for long-term decisions are kept for the long term. All right, so you've mitigated knowledge. Good job. Users are slowly rebuilding confidence in your service again. You want this phase of the cycle to last as long as possible. At Google, we found that the most common trigger of outages is a code or config change. So to maximize time between failures, we should just stop all changes, right? Well, that might work for a little while, and sometimes it's a really good idea, like during the one weekend in the year, you make all your annual revenue. But in general, you don't want changes to stop. There are always features to push, bugs to fix, new hardware to support, and new threats to counter. Changes, however, can be made safer. Let me go back and fix what I just said a second ago. You don't necessarily want this phase to last as long as possible. Some companies can laser focus on this. It turns out that's the wrong thing to laser focus on, and it's probably the wrong thing for you to focus on too. What happens if you go too long without an outage? Your all callers get out of practice. And when you finally do have an outage, and you will, the outage is much worse than it would have been otherwise. Also, companies that prioritize time between failures too highly often slow their releases down to a crawl. And this is bad for a lot of reasons, like lost dev velocity and poor response time to market forces. In general, it's better to focus on shrinking your time to detect and time to repair. Maximizing time between failures largely comes down to discipline and a recognition that anything that depends on a manual process is slow and error prone. This means that you need to focus on dev practices. Fostering a culture of quality in your dev teams is a critical component to maximizing time between failures. Code reviews are also important as it allows for higher quality code, and having test coverage requirements well defined at the start brings it all together. Next up is continuous integration and continuous delivery. This is how you can deploy changes with reasonable confidence that they won't blow up in prod. Sometimes they blow up anyway, of course, but CI/CD will keep the issue fewer and smaller. You need to automate your tests. Those include unit tests, integration tests, end-to-end tests, and rerun them often to catch regressions. At Google, we run automated tests on every code change request, and we simply block the change from being committed until all tests pass. And you want continuous delivery so that you can get new code out as often as possible. This way, each release will be small, which means smaller things can go wrong. It also means it's also much easier for you to figure out what went wrong when only a few changes change in a release. It's very common, for a lot of companies to do big bang releases, and if something goes wrong, troubleshooting and try to figure out what went wrong is complex. I want to talk about something really important with continuous delivery, though, and that's gradual rollouts. Gradual rollouts allow you to discover problems and roll back before all users are affected. We call this canary analysis. Roll out just to a few users, see how it goes, compare error rates for those users to the users still in the old release, roll out a little bit more, go slowly. This is how you flatten out the sadness scope on that graph that I showed before. All this filters down to the dev side as well, since there's always at least 2 active versions of the code. You need your code and data structures to be both forward and backward compatible. You need your services to work when half of your services are running one version and the other half are running an adjacent version, or when data stored by version X has to be read by servers running version X-2. You need this not only for gradual rollouts, but also for rollbacks in general. Next is about your service architecture. What makes your architecture robust? Your architecture is robust if it continues serving your users despite significant internal failures. Think redundancy, no single points of failure, and graceful degradation. That means reduced functionality during outages, not no functionality. Let your architecture evolve over time as you discover what works and what doesn't. When you write a postmortem, think about what failed and how you can make it not matter so much when it fails again. And finally, chaos engineering. Let me just say, I really don't like this name. We're not trying to create chaos, we're trying to create resilience. When you see the term chaos engineering, think resilience engineering. Anyway, why use it? It's about probing your limits by creating controlled failures. It essentially allows you to learn the lessons of an outage without any actual impact on your users. You pay in the engineering time you took to prepare the test instead of with your users' goodwill. You think your architecture is best? Poke it and verify. When I talked before about disaster recovery testing, it was for training people, but you can test systems this way too. And the cool thing is, it can all be done automated. Oops, sorry. You write a test to break something in production, and what do you expect? You expect nothing happens, at least to your users. You can keep your architecture strong by consistently breaking stuff, and your service stays within SLO. The last key area of SRE is a cultural one. It is the ability for SREs to regulate their operational workload. We define operational workload as things you need to do to run the service that manual, repetitive, automated, tactical, without enduring value, or that scale linearly with the service growth. Operational work is important. It gives you the experience you need to improve your service and design better systems. It's also what tells you what to automate, but you cannot automate everything, and there's always more. However, if all you do is operational work, you're no longer an SRE. And so Google enforces a strict policy of capping the amount of operational work at 50% of one's time. As I've said, SRE is treating operations as a software engineering problem. Therefore, you want to hire people with software engineering skills. What we found works best is to have a mix of software and systems engineers. System engineers take a holistic approach to the connections between distinct software systems and services, rather than one, the internals of how to build a piece of software, where software engineering has tended to concentrate as a field, and two, how software artifacts are deployed on specific hardware, which has been the historic domain of system administration. Instead, system engineers view the collection of individual pieces, which may be built by separate product development teams, as a whole with properties distinct from its components. Each of these, software engineers and systems engineers, bring a different but needed perspective to the role. And you really need to have both to have a really well-functioning team. It's important to also remember that system engineers do not equal toil. Don't conflate 50-50 software engineers, system engineers split with 50-50 toil number. That's not what we're saying. So you don't just give all your toil to the system engineers. It's 50% of the time for the system engineers as well as for the software engineers should be operational work. Finally, I want to emphasize that empowering SREs is really critical. They need to be able to say, you know what, our error budget is in danger. We need to spend more time on reliability, which may mean slowing down future releases. It's hard to get the right mix of skills on an SRE team. And so once you've found them, you don't want to burn them out by burying them in operational tasks. And instead, you want to help them find the value that work is going to help them, that work's going to help bring in their careers and deliver value to the business. These 5 areas we've talked about are the key practices to implement SRE. You can have these on your team even without having a separate SRE team. We found these practices to be really valuable in supporting these engineers, and you want to make sure they're rewarded for this kind of work. You want to make reliability something that you reward in your culture. It's very common for an organization to praise launching or shipping something, but not so much the maintenance of that thing. And so making sure that making something highly reliable is rewarded just as much as launching something brand new is critical to building this culture. Combining SLOs, error budgets, and the practices we've talked about gives you the full implementation of the DevOps interface. So how to get started? I recommend you do these 4 things. Define an SLO. If you don't have a measure of reliability, you have no idea how reliable your service is. And remember that you can start really simply. You need to hire people on your operations team who write software, or upskill people in the team. It's not an either-or thing. You can do both. People working in operations need to be enthusiastic about automation and have parity of respect with the product development and software engineering teams. Finally, you have to have that feedback loop for self-regulation. You need to have people who can pick their work, people who are able to push back and say, you know what, we can't really support this new product right now because we're overwhelmed with what we have right now. You can do this, start small and let it grow. One service, by having one service a strong exec sponsor and support, fostering the right culture, measuring reliability. You don't have to shoot for perfection, just improve over time. Once you have success, build on it. Spread the word, and in my experience, other parts of your company will start lining up to learn how you did it. Let Google help reduce this friction via shared monitoring or other collaboration on our Google Cloud platform. We believe that SRE is an effective way to be reliable in the cloud. I believe that these two arguments matter the most. The idea that effortless scale should not mean that you also have to increase the number of people working on operations or that your teams will get buried in operations. If you focus on prioritizing for operations and reliability, your services can run better without needing more people. The other thing is that it's important to highlight that you don't have to have this tension between product development and operations, and instead that if you have ability to agree on whether the system is reliable enough, you can then choose whether to invest in more features or in more reliability. Then you can make the decision at any point in time by mutually agreeing rather than playing tug of war. Just wanted to share, these are some really great resources if you're interested in learning more. I have only been able to cover some of the key points, but there's great books out there from O'Reilly, published by Google, for site reliability engineering. The first one, the second book, Site Reliability Workbooks, they teaches you how, takes you through how to implement an SRE practice within your organization. And then Seeking SRE book is good as well. And so with that, I wanted to open it up for questions.
Yeah, very, very interesting session, Emmanuel. Lot of questions have come up. I will start with a couple of them initially. So you talked about error budget and toil budget. Can you throw some light on those? Because these are, definitely not predictable ones. Highly mature practice.
Yeah, so they're two different things. So error budgets, you can think of that being more of your nines of availability. So you have 3 nines of availability. That's going to give you X amount of hours per quarter that you can be down in your service, and you track that very closely. And so you have a running tally of where you are in terms of your error budget for a specific quarter. And if you are running over or close to that, then you may want to slow down new things that you're pushing to production because your service is being less reliable, and you may have to prioritize focusing on reliability instead of launching new things. So that's kind of the focus of error budgets. For toil budgets, toil is more a lot of that manual work, a lot of those manual tasks. So operational work, operational workflows. We use toil as a term in Google to relate to anything that's kind of manual, grunge-heavy type work of someone has to do something that's not automated. And so there's a constant drive within SRE to automate away toil. But with that said, you also have to look at what is the cost to automate away that toil. I'll give you an example. So if you have, if you say, hey, we have this operational task that takes one person an hour to do every week. It's something they have to do for 1 hour every week. And so should we automate this? All right, what's the engineering lift to automate that? Oh, so to automate this, it's going to take us 2 quarters of 3 FTEs to automate this away. Okay, that's probably more of an eng lift than just continuing with the 1 hour every week of continuing that toil. And so that's kind of the decision that you have to make, as a product development team in partnership with this SRE team is, should we invest in automating this thing away, or is the engineering lift that would be required to do that better being spent elsewhere? That's kind of the analysis you have to do. But toil in general at Google, more, SREs, are not operations folks. So, they are required to like I mentioned before, treat operation problems as a software engineering problem, or software development problem. And so as part of that, people are required to spend not more than 50% of their time working on operations work, to allow them to invest that energy in their own personal career development and growth, in growing as an SRE by focusing on some of the more software development type problems. And so if someone isn't given that opportunity to do that, then they can't grow in an SRE and the organization doesn't get better over time. And so we focus really closely on ensuring that SREs don't go over 50% in terms of toil or operational workload. And that's policed very heavily by SRE managers, site reliability managers, or SRMs. And it also could mean that, like I mentioned before, if an SRE team for on-call support, basically the dev team wants to hand the pager to the SRE team, and that increases the toil significantly on the team, the SRE team will hand the pager back to the dev team and say, hey, we need to improve the reliability of this before we accept this pager, because it increases the toil on our team to an unreasonable level. And so that's just a balance that has to happen with the SRE organizations and the development organizations, and why it's more of a collaboration as opposed to throwing it over a wall, because the SREs have authority to kind of hand the pager back to the devs if something wasn't built with reliability in mind, meaning the SREs were actually pulled into that process early, as opposed to just being handed them, handing an application after it's already been built without reliability in mind.
Okay. To get a sense of the quantum, for example, I don't know whether you are free to share this. YouTube, what is the kind of Toil budget? Some indications.
I don't know if I can share anything related to that, but I will say that we very closely monitor Postmortem, and so there's some noise.
Sorry, those who are not speaking, please be on mute. Somebody 53244. Please mute yourself. Sorry about that, Emmanuel. Somebody, they are not aware.
I'm very familiar with Zoom world, and Google Meet world, it's like it's the world we live in now. But yeah, sorry. So what I'm saying, so with is there echo?
Yeah, the Toil budget. You're talking about quantum.
Yeah. So for YouTube, we focus a lot on postmortems. So postmortems is a very important part of our culture, and understanding. That's primarily a lot of where my focus is organizationally is looking at incidents and trying to figure out, identifying trends, trying to think about how we can move the dial across the organization in improving reliability from trends that we see in postmortems. And so there's a huge organizational focus on this, to the highest levels of YouTube. And so we care very passionately about, service availability, because our platform is a very large platform, and it's very it's rare that all of YouTube will be down, but there may be instances where a subset of users are impacted, and we try to minimize that as much as possible. But outside of that, I can't really share like any specific error targets.
Okay. Yeah, we understand. The other thing is, I know Google is fantastic on AI. So how much of your, for example, a YouTube downtime is predictable versus really uncontrolled or whatever?
Yeah, so I think the way I can answer this is we have goals of organizationally that we commit to for for, how many types of outages we will allow per year, right? So remember I mentioned before that we talk about, incidents of different varying levels of severity. So, we have very clearly defined severity guidelines that define severity levels for incidents. And so we track that at an incident level in terms of the severity with how many types of incidents that we would allow in an organization. And so that's probably the most I can do to answer that question. But that we do look at it more from a severity perspective, with our classification of incidents.
Okay, fantastic. Yeah, you see, we have a lot of questions that have come on chat. So instead of me reading out the questions, I'm going to ask the individual to directly ask the question. Mr. Kumar Venkatesan, can you please unmute, ask your questions? I know you have multiple questions.
Yeah.
One by one.
Yeah. First of all, thanks, Emmanuel, for the wonderful session, and also Mr. Rajaram for arranging this. I have few questions. Mainly, are the SRE, SMEs, or architects needed to be in the cloud-based projects, programs, and how different are they from the normal cloud enterprise architects? That is question number one. And number two is something, on the chaos engineering also you can enlighten, or if you can give us pointers where we can see. And the third question was, are there any SWAT teams who handle this downtime, or, because the time window is very short? That's all my three questions. Thank you, Emmanuel.
Yeah, so for the first question, that was around, so let me just bring up the chat real quick. Just so I can make sure I answer all of them. So we, in terms of roles, how we structure things internally is a bit different than how you might structure it, from a cloud perspective, because we, our systems are custom built in many ways for YouTube, just given our scale. And so a lot of the backend infrastructure is, to like an outside observer, it might be like a cloud, but internally it's specific to YouTube. And that's not always the case, but I think for us, for SREs, SRE itself is a discrete job family that is focused on the reliability aspect of an application, and so I wouldn't combine that. I guess to ask a clarifying question. So with this, are you asking for a mix of the types of roles in a team, or are you trying to understand the difference between the roles?
Yeah, that's right. The difference between the roles, basically. Yeah, you're right.
Got it. Yeah, I think looking some of these standards are more cloud specific, but I would say for architecture type roles, those are more for building environments within cloud-based architectures or cloud-based platforms. So like on GCP, you have a cloud architect who will help set up the environment, usually migrating from your on-prem solution to your cloud solution. But I'm not a GCP expert. That's a different domain, so I can't speak too much to the cloud side of things. But from an SRE perspective, SREs are focused on the reliability of an application. And so they work usually in partnership with a dev team, which may have architects on it. So a dev team may be made up of, a technical lead, an architect, software engineering teams. And then you have your site reliability engineers who are specific to the reliability aspect of things. So they understand how the infrastructure works. They understand how your different monitoring tools, how your different alerting tools work, and they're helping to set up, reliability best practices with the application as it's being built and deployed by the development team. So that so SRE is a very defined skill set that is independent of those other roles. And so
Yeah,
the SRE book, it really goes into a lot of detail on the SRE job function, because it's very deep, and you know, I've just kind of touched on it here, but there's a lot there that kind of speaks to the value of having someone who's dedicated to just focusing on reliability. And then to your second question around chaos engineering, so a lot of organizations, you know, you've heard about you know, organizations that intentionally try to break their applications internally, you know, or do things that, you know, or, you know, you might have heard the term like mutation testing and things like that. You know, a lot of that is done to try to see what happens when the application is exposed to something non-standard. You know, it's a way to kind of make your application more stable, more, in some cases, more secure from a security standpoint. And so chaos engineering is more focused on, you know, breaking your application internally so that, you know, your users experience less outages. And so there's a lot of good resources online that talk about chaos engineering, and that domain. Mutation testing is a good area to read up on. I would recommend taking a look at some of that stuff.
Sure, thanks. That gives a lot of pointers.
And then is your last question was
we have Shubha. Shubha, can you unmute and ask your question, please?
Hi, Emmanuel.
hello.
Hello. So my question was, like, some of our maintenance projects, the development is done by a different supplier and we do the maintenance. So in that kind of a scenario, will SRE work? And my second question was, when you were explaining time to detect, time to repair, or time between failures, it was sounding similar to the older concepts coming from ITL legacy, saying MTTR, MTBF, and MTTF. So in that case, can you give some examples of how do you define your SLOs or SLIs, so that it will give an idea as to how different it is from the regular metrics? These are my two questions, Emmanuel.
Yeah, for the first one, that's a hard one, because I would ask, does the team that do the maintenance have any type of ability to influence the development of those applications? Or is it simply, you know, a transition with no type of what was it?
Okay, so it's basically like you have several suppliers, and we will do the regular service application management maintenance part, which will include all the incident resolution, problem resolution. In fact, when you bring out the problem fix, it's going to be done by the other supplier who takes care of the development work. So it is a pretty complex kind of an engagement. So in that case of a scenario, I just want to know if SRE works, or both the dev and the operations team should be from the same supplier.
Yeah, so I think in that instance, it would depend very heavily on the leverage that the organization, like the maintenance organization, has with those other partners. Because if you can say, hey, we're not going to accept this because it doesn't meet our bar of reliability, then you have some authority to kind of bring in some SRE practices to help force, I wouldn't say force, but help kind of drive a reliability culture. Because it sounds like it's more set up kind of like the traditional, like throwing it over the wall type of scenario. And that's really difficult. That's really difficult to implement SRE practices in, because if it's just being thrown over the wall and you're not on an equal footing being able to say like, hey, you know, influence the culture, or you know, have site reliability engineers come in and actually, you know, help influence the actual design of what's being built, then it's very difficult to implement SRE. And usually in those types of situations, you'll have to get executive sponsor support in order to drive some of that change. So that might be a situation where you kind of identify an executive sponsor who, you know, who cares about reliability, at least, you know, at a high level, and then help them kind of leverage them as the person who kind of becomes like the reliability champion, to kind of put some, to kind of establish some equal footing. But it's very difficult without that executive sponsorship to do something like that. So I think in that scenario, you would probably have to start with finding some executive sponsors who care a lot about reliability, or who you can convince to care a lot about reliability, because that's another way to kind of shift the organization in a different direction, is by showing how improvement in reliability will save money and will cause things to be delivered to market faster, as opposed to what a lot of people think about reliability, which is slowing things down. And so, you know, showing those benefits, that's actually what will come out of it, is critically important. And so there's the SRE workbook, the second book on the previous slide, might be a good one for that one, because it actually talks through how to implement SRE within an organization. And I think it kind of highlights the importance of executive sponsorship and how you can kind of put together some metrics to kind of show that value. And to your second question, you know, the key metrics to think about from an SRE, the SREs care about are, you know, time to detect, time to mitigate, and time between failures. And I did a deep dive into those areas because those are the ones that when you look at a postmortem, which is an analysis of an incident after the incident, that's usually done right after the incident happened, you know, and it's trying to understand why that thing happened. Those are the things that you actually want to measure, because the question that what a postmortem should cause is, if this exact same incident were to happen again in the future, did we reduce either our time to detect, our time to mitigate, you know, or was it, you know, did we substantially increase, you know, the time between a similar failure because we eliminated the previous failure modes? And so those are what I would say the three key metrics are from an SRE standpoint that we care about in the SRE world.
And when you say SRE is a specific role by itself, so do you have any certifications that guide such kind of roles so that people can take it up?
I'm not sure about certifications, but the SRE role is actually a job role. So it is a clearly defined role with a set of responsibilities. A lot of organizations, Google piloted the SRE, not just the SRE philosophy, but, you know, SRE engineers or site reliability engineers, and then other organizations started to adopt them. So you can see a lot of companies now are actually hiring for SREs, like an actually defined job role. And if you want a good description of what that job role might look like, I would check out the workbook for the SRE workbook and the SRE general book, because they go into a lot of detail about what the responsibilities are of an SRE, and even more importantly, what the responsibilities are not for an SRE.
Okay.
Yeah.
Okay. Thanks a lot, Emmanuel. That helps.
No problem.
Yeah. Now I would like to request Purna to unmute and ask your questions, please. Purna? Purna, are you there?
Yeah, hi.
Hello.
Can you hear me?
Yeah.
Yeah.
Yes.
Yeah. Hi, thanks, Emmanuel, for the very informative session. My question is more to do with the AI playing the key role in all the self-healing applications, and I mean, even in analyzing where the failure is happening and whatnot. So how much do you think the SRE part is already automated, and where do you think the future of AI's role in SRE?
Yeah, you know, I think Ben Traynor has been very public about, you know, ideally you want to eliminate as much operational work as possible for an SRE or Toil, as I mentioned before. And so, you know, at Google, we've automated away a lot of the standard operational type stuff that you would normally see happen in a data center. with system engineers, and so it's critically important to invest in that type of routine maintenance type of work, automating that away, because that is really the general basis of toil. I mean, I worked in a data center, early in my career. Like I was a system engineer and a network engineer, and I did manual work, right? Like a lot of toil, per se, in my previous company. And a lot of that stuff, we don't do at Google. Like all that's handled by machines, right? That's handled by technology, because if you're just manually configuring a device, or inputting codes, that's just an opportunity for failure, right? That's just an opportunity for something else to go wrong. And so ultimately, what's driving the automation is, how can we prevent a failure? How can we prevent an outage? If it takes a human to manually configure this machine every time we bring it up, well, can we automate that so that every time it's brought up, it's flawless, it's perfect, right? We don't have to worry about someone fat fingering something, or essentially typing something incorrectly into the prompt. So it's really important to identify where are those failures happening. And usually, especially if you're implementing SRE for the first time, you start doing postmortems, and you start actually taking a look at the incidents that happen and seeing what the failure modes are. Those become your areas of immediate automation focus, right? So if you discover that your Windows team regularly runs into production issues due to a misconfiguration on a Windows server they brought up, and that requires rework and outages and troubleshooting, well, find a way to automate that infrastructure, right? Eliminate the human component so that it's not being manually configured in the future. And not only do you eliminate potential incidents in that realm, but you eliminate that toil and free up those engineers to work on more fulfilling work, and or automating other things that allow them to not just enjoy their work more, but also grow and develop in their careers.
Yeah. The one aspect is the repetitive task being automated, as you rightly said. The other thing is even self-diagnose. I mean, self-diagnosis, self-healing applications. So those part of it, how much is the maturity level you feel from your standpoint? And
I can't speak so much publicly from a Google perspective, but I will say that we invest very heavily in automatic remediation, and preventing, for a lot of the things that are kind of standard, right? Like, capacity issues, right? Do you need to manually increase the capacity every time, you run into an issue, right? Is that something that has to be manually done by a human, or can that just be automatically done by a machine? So that's a question, to think about in terms of whether or not you invest in, machines fixing machines. Is, what are the things that we're okay with automatic remediation for? And at Google, I can't talk about specifics, but I would say that we the perfect world is a world in which, a lot of the operational day-to-day stuff is automatically handled by machines, not just in terms of configuration, but in terms of failures and automatic recovery. So it's very common, for something to fail, but not fail fully, and to recover on its own without a human being involved. And so that is something that is expected, and that is built into our technology.
Sure. Thank you.
Yeah, at this time, I would like to request Thiru to unmute and ask a question, please.
Yeah, thanks, Rajaram. And thank you, Emmanuel, for a great session. My question is this, Emmanuel, right? Like you said, mean time to detect, mean time to mitigate, and time between failures, all are critical, right? So when I think in a different perspective, for anyone to give a quick mitigation, they need to, not all the issues can be self-healed, right? They may want to recreate the issue in their own box for them to do a thorough testing, and then, or even to identify the root cause of an issue to fix and deploy. So I would like to understand at Google, what is the practice that we have in enabling a truly integrated environment, especially with your interfacing teams?
Yeah, I think an important aspect here is logging. And so at Google, we care very passionately about logging, and logging, to identify failure modes, right? So you can't analyze what you don't have, right? And so if you're not capturing, the states of your machines and what's happening in a detailed way, how will you know what went wrong outside of recreating the exact same scenario, right? And if that same scenario involves user traffic, well, that's problematic, right? Because you don't want to inject failure into your infrastructure that's going to reduce your revenue and cause your users to be unhappy just to figure out what went wrong, right? And so it's critically important that when an incident happens, that you have the data there to do an in-depth analysis to understand what did go wrong without having to recreate that exact same issue. And so knowing where to look is really important. So it's really, I would say it's very common, say, for you to have a postmortem, and if you can't identify what went wrong with an incident, and you'd have to recreate the incident, for that to be an action item coming out of that postmortem to say, we need better monitoring because we didn't detect anything wrong here, or we don't know what happened. And so we need to build monitoring to understand what happened so that if this issue happens again, we can detect it and we can detect what went wrong. And so usually those are good ways to identify monitoring gaps in your environment and build in that additional monitoring so that you have that logging available to then go and do those in-depth analysis to understand what happened when an incident happened without having to recreate it. Because you never want to be in a situation where you have to tell your CFO, hey, we're going to bring the application down and we're going to lose a couple $100,000 because we need to figure out what went wrong, right? Like that's not a realistic scenario, right? So you want to make sure, if an incident happens and you don't have the data to do an analysis, that you identify what monitoring needs to be put in place so you can capture that data the next time it happens. And in the Google world, it's if it happened once, chances are it'll happen again. So it's better to just wait and see if it happens again with that additional monitoring that you put in place to catch it. That'll give you more detailed analysis. And if that's not acceptable in that it was a significant outage, then you may need to spend some time building a sandbox environment to do an analysis, depending on, if it's a critical revenue generating part of your business, then the engineering effort to do that may be what you have to do. But it's always difficult because you're recreating something, and it could potentially be something that was misconfigured or something that wasn't done properly in the environment that's in production, versus you creating that in a sandbox environment and you don't recreate that same scenario that causes that failure mode. So it's not a perfect solution, but I would say invest in logging, invest in understanding, invest in monitoring. Good monitoring tools are critically important.
Thanks a lot, Emmanuel.
Emmanuel, in the SRE world, the return on investment, are there any numbers, metrics, which can be potential selling points?
It's a good question. I think usually you want to look at what your error rate has historically been. So a lot of what they've been experiencing is they've been experiencing a significant number of outages that have led to some calculatable revenue loss. And so if you look at that revenue loss and you say, hey, last year we lost, $2 million because of outages, right? Then that could be a justification to say, hey, if we hire, 2 site reliability engineers, at a fraction of that impact, we can probably reduce the amount of, and I'm exaggerating, 2 is not going to give you what you need, but just for the sake of the example, investing in making a case from historical revenue loss is usually what causes organizations to recognize that they need to invest in hiring site reliability engineers. So that historical, and if you don't track that, organizations may not know how much money they're losing when an outage happens, because it doesn't automatically translate. Like, you need to have good processes in place to understand what your revenue loss is per second or per minute, right? It's not a number that you can just easily calculate unless you put in place those processes to do that. And so a lot of times starting off maybe simply capturing that data to be able to quantify that to a leadership team to say, hey, we started tracking how much these outages cost us. And we just want to let you know that last year we lost $10 million because of outages, right? Like, when you give someone that number, that's very powerful, because then they go, oh, $10 million of lost revenue, how do we fix that? And that's usually like, oh, it's a thing called site reliability engineering that's focused completely on reliability. Let's set up an organization, right? But sometimes if you don't have that revenue data, the first step in getting is usually building a way to identify and track that. And sometimes it may be manually calculating that from through in-depth analysis by a few people. And so, but that's usually the first step, is identifying the revenue impact, historical revenue impact.
In terms of investment, it is not only manpower, but also softwares and systems. So how much is the quantum there? Like, do you recommend any specific softwares, specific investments?
Google Cloud. But I would say, I think, in all seriousness, it's a lot of the reason why organizations are shifting to the cloud is because of that expertise that comes with hiring a cloud service provider. Google is very open about, hey, when you get GCP, you're not just getting a service, you're getting our expertise, right? And so that's really helpful, because when you're trying to, say, migrate an application over, to GCP, you're going to have experts that see hundreds, if not thousands, of applications and go, hey, you can improve this thing in a number of key ways, and here's some recommendations for how you would migrate this or rebuild this on a cloud platform. And so, there's a lot of benefit when you do migrate to a cloud environment like GCP, where you get some of that expertise and some of its resources. And Google actually does do, they do, I think, depending on the size of the contract, they actually do have like SREs that would be involved with helping to maintain your application. And so that is, for an organization that maybe doesn't want to staff up their own SRE team, that is definitely something that some organizations like when they move to a cloud service provider. In terms of other tooling, I think I'm trying to think. At Google, we build all of our own stuff, so we don't really have. So I can't really say like, hey, there's this great third-party tool that you should use, because we don't really use third-party tools. But there are some comparable. I'm trying to think. There's a good monitoring tool. I'd have to look it up.
I know you have the challenge of thinking away from Google.
Yeah, it's like we Google's we build our own stuff. We run, you know, we're a software engineering company, so we like to build our own things, completely control it, and especially with a lot of third-party tools really break down when they're introduced into our environment just because they're not designed to handle the Google scale. So we end up having to build our own stuff. It's very difficult for me to like think of like, here's some great third-party tools.
Very true, very true.
But I would say at least some tools from my prior to Google experience that are pretty good for automation are things like Puppet and Chef. You know, they're good automation platforms for like server building and software deployment. So, you know, it's Subversion for version controlling. If you don't do version controlling, you know, different things like that. But that's pre-Google tools. That the industry may have changed in the past, you know, since I've been at Google.
Yeah. And yeah, before we close, one last question. Where do you see the future in this area? Next 3-4 years, how is it going to present?
I mean, I could probably talk more broadly. I would say that, you know, I think SRE is a growing field. I see more and more companies hiring for SREs now. I see more and more companies that are starting to adopt SRE practices and build up and staff up their own SRE teams. So I think, you know, the kind of traditional model of having an operations team that's separate from a software engineering team, that's separate from a testing team, you know, that whole old model of building software is kind of dying. And I think you're starting to see more collaboration come into the space. And I would say over the next few years, you're going to see more organizations recognizing the need for having people who are focused on reliability, who have that kind of mixed software engineering, system engineering background, who can come in and re-architecture, especially with migrating to the cloud. I think you're going to see more of a need to build applications that are reliable, because I think, you know, when you get to the cloud, you know, the excuse of, hey, the infrastructure is broken doesn't work anymore, right? Because a lot of instances, it's not the infrastructure that's broken, it's something within the application itself that breaks, that causes your application to go down. And so the need, I would say, for people who are getting into the nitty-gritty of or the details of you know, application reliability is going to only increase as we migrate more into the cloud. Because, you know, historically, a lot of blame has always been placed on the infrastructure side of things when applications break. And I think that excuse is going to start slowly vanishing for dev teams to use. So I think that's going to lead to more of a drive for the need for people who focus on with a reliability background. And I can say, just from, you know, seeing within our own SRE organization at Google and the demand outside of Google, that the need is definitely growing for experienced software site reliability engineers. So there's definitely a hot field to get into if you're a system engineer, or if you're a software engineer who likes infrastructure. Becoming an SRE is a good career decision right now.
Thanks a lot, Emmanuel. I think, you know, very, very insightful and inspirational session. I'm sure there are lots of people out there who will now consider SRE as a serious business in terms of, I know it is going to become a specialist effort in this area. So thanks once again for staying back late in the night.
No problem.
Thank you very much. And we will be in touch.
Thank you.
Any chance of you traveling to India anytime?
Maybe after things have opened back up with COVID going away.
Okay.
Yeah, but it's definitely a place I've wanted to get to for a while. My great grandfather was actually from Mumbai, so
okay.
I've always wanted to come to India and just kind of, you know, experience you know, that side of my my family that I haven't had much interaction with.
Sure. We have an open invitation for you to be at Chennai, all right? We would like you at Chennai if you happen to. Definitely.
Would love to.
Thank you very much, everyone, for being part of this session. Thank you.
Thank you, Emmanuel. Thank you, Rajaram.
Thank you.
Thank you very
It's
much.
great. It's great getting to meet all of you virtually. And have a good day on your side.
Yes, it is about 11 a.m. 11:07.
Yeah, I'm gonna go to sleep.
Yeah. Thank you very much for staying.
No problem. All right.
Thanks, Emmanuel. Thanks, everyone.
Thank you.
No problem. See ya.